Thank you, everyone, for attending the first webinar sponsored by the Association of Environmental Studies and Sciences. My name is Will Burns, and I'm the president of the association, or ACE as it's known. ACE is a interdisciplinary academic service organization that seeks to foster interdisciplinary environmental research at both U.S. Academic institutions with environmental studies programs or allied programs, as well as programs throughout the world. And the purpose of our webinar series is to highlight cutting-edge research that is being published in ACE's journal, which is the Journal of Environmental Studies and Sciences, or JESS, a publication of Springer. And so with that, I'm pleased to introduce today's speaker, Dr. Laurie Johnson. Dr. Johnson is the chief economist at the Climate Center of the Natural Resources Defense Council in Washington, D.C. Prior to joining NRDC, she served as a professor in the economics department at the University of Denver for 8 years. She obtained her PhD in economics from the University of Washington. And at NRDC, her work focuses on macroeconomic modeling of climate change legislation as well as its distributional impacts. And today she's going to focus on some new research that grows on a study that she published last year, also in the Journal of Environmental Studies and Sciences, which focuses on a critical question for domestic climate policymaking, which is costing carbon and conducting the requisite cost-benefit analysis that's required legislatively. Obviously, this kind of research and capturing the externalities and determining the ultimate cost of carbon and incorporating that into our calculus of what would be optimal from a standpoint of climate policymaking and energy policymaking is a critical consideration. And so we think this research, which seeks to incorporate research of NRDC as well as research being conducted in the U.S. government, is extremely important, and we're very pleased to have Dr. Johnson with us today. And so, with that, I'd like to pass the baton to her to begin her presentation. One moment, and I will hopefully effectuate that.
Okay, great. So. Thank you very much for having me. It's an honor to kick off your very first presentation in your series. And today I am, as they said, going to talk about the cost of carbon pollution and how it relates to the President's Climate Action Plan, and drawing on some of the research, both actually in the first paper, to give you some background, as well as the one that was just published in the journal. This is, in fact, the best PowerPoint slide deck prefab slide that's available, as you can probably guess why. I like it. So let me, with that, begin the presentation. Okay, it's not going down on my screen. Just a minute. Oh, there we go. Okay, so the outline I will give you first is just to give some folks in the background on the SCC, the social cost of carbon. We like to call it the cost of carbon pollution because social cost doesn't mean much to a lot of people. It's economist kind of jargon. So I'm going to say basically what it is, its structure, how it's estimated, some of the damages, climate damages that are in there, and then explain a little bit about discount rates since they're a critical input to determining its value. Then I'm going to talk about the different SDCs that the government's using and that we estimated in the paper, which basically vary by the discount rate. And then I'm going to say something about basic, the bottom line in terms of policy, which is what these costs mean in terms of what would be effective, most cost-effective for our reducing emissions from our power plants. Then I might say just something quickly about what was just done with the administration. It updated its 2010 SEC values, which has become a bit of a kerfluffle in the Washington scene, because as you'll see why, it really matters. So then I'll take your questions. So the SEC is present value of all of the economic damages caused by a unit of emission in whatever year you're looking at of carbon dioxide, one ton. It increases over time as climate change progresses, becomes increasingly worse, and it measures an incremental reduction. So this is appropriate for regulatory analyses because when we're basically going to deal with climate pollution as it is now with the Clean Air Act, not because Congress can't seem to do anything about it. So we're using the Clean Air Act, and that means we go source by source, regulation by regulation. It's not ideal, but that's the way it's done. And so with each regulation, you're looking at an incremental change, which is what the social cost of carbon measures. This is not an appropriate number to use for large changes in emissions. So you can't just take it and multiply it by a very large change in emissions. It does not, I should say, directly correspond to a carbon tax or a permit price with a target that's economy-wide. It may or may not equal that. It depends on your target, just sort of a point of reference for people. And we can view the SCC as a minimum value that we would want to use for policy making for reasons that I'm going to cover in the presentation, which pretty much have to do with the fact that it's missing a lot of damages. The rates that the government is using are quite high for discounting, and there's also a lot of aversion to catastrophic risk, which is not taken into account in the SCC estimates. And that is what the science tells us is possible, is catastrophic outcomes from climate change. And those are what we care about the most. So the SCC is estimated with what's called an integrated assessment model. And what that does is integrate, as the title says, basically the climate science with economics. We start with the socioeconomic trajectory. What does economic growth look like? What does the population growth look like? Then what does that translate into emissions? And then what does that translate in terms of climate impacts? So what are the temperature change? I'm missing a link there. It should be a temperature change, sorry. Temperature change then translates into climate impacts. So, for example, a certain level of sea level rise would be an impact, and then that would be monetized. So, for example, property values would be subsumed, flooded, would be monetized, and then those damages would be discounted at a discount rate. So, for my initial introduction, the left side of this is what's typically in the models, and the right side is what's out. What you'll see is that the list is much shorter on the left side first, but also what you see also is that the things that are in this measure are much easier in general. By no means are they easy actually to measure, but they're much easier for economists to measure, and therefore they're what's in the models. So, for example, we look at average temperature changes and how much crops produce. Slight increases from colder climates will give you expanded production. Temperatures above the optimal growing will lower your output, so we capture both of those things. Property damages or losses from sea level rises and flooding, coastal storms. Energy demand, so we get expenses from more cooling, savings from less heating, and then public health outcomes like deaths from heat waves, and on the other side of the coin, less deaths from cold weather. That's a small list, and in fact, on the right side are things that we arguably might care about a lot more and are far more damaging. So we don't have ecosystems, coral reefs, for example, ocean acidification, which could very dramatically disrupt our food supply in the ocean, species extinction, biodiversity, the different ecosystem services that go with that, air pollution, for example, smog. With higher heat, you have more pollution. You have a lot of associated health damages with that, cardiovascular, respiratory, other damages. Agricultural damages from temperature extremes. So this is very important because it's the extremes that really matter, and the models just look at averages. So when you have these extreme heat waves, that's where you're going to see a lot of the impacts. Drought and forest fires are not captured. Food price increases from any food shortages, decrease in supply from drought, for example, are not captured. Interaction effects, so for example, there's a storm surge that's worse when you have sea level rise. And that's pretty much what did a lot of the damage from Sandy. Drought interacts with how much water is available. It interacts with the level of forest fires. The water itself that's available interacts with our energy system. We need a lot of water to cool our power plants. There's negative feedback loops. So something releases gases. It causes warming, which then causes more warming, and then it goes in a negative feedback loop like that. So methane release from the frozen tundra in the Arctic is an example. Sea ice actually reflects some of the heat, sun's heat back out, and as the sea melts, the ice melts, we have more dark area, which absorbs more heat, and so forth. You go back into the cycle. Catastrophic events that might lead to mass migration are not in this. So you have extreme storms, if the ice sheets collapse, sea levels are up. If one of them goes, we've got 20 feet sea level rise, we have mass migration. We have extreme drought, loss of water supplies from glacial melting, which irrigates millions and hydrates millions of people, so forth. So that's pretty much what we're facing and what's not in the models. Now I want to say how the discount rate works. It can be, I don't know if people can see this little thing on my screen, but it has the NCE, hopefully not. It's just cluttering this page, but sorry if there is there in any event. So the interest rate is the discount rate is like an interest rate in reverse. So the easiest way to explain is just an example. If we have let's say we have $105 in climate damages, and that happens next year, and we're considering a 5% discount rate. Consider the reverse of this. If you had 100 today, and it grew at 5%, it's 105 at the end of the year. Discounting it from the future value of 105 to the present gets you back to 100. That's all that discounting is. It's just basically like an interest rate in reverse. And the rationale for why economists do this, may or may not agree with them, but this is the rationale, is that future wealth, we assume, is growing, as it has historically. So to the extent that people are wealthier in the future, that wealth can cancel out the damages. Above that cancellation, let's say there's more income than there is damages, that value of that wealth is not as much, it's not as valuable to us. We get less utility, as they say, per dollar. So $1 to a very poor person is worth a lot more than $1 to a wealthy person. That gets at that notion of the marginal utility. And then finally, we simply like things now rather than later. We're impatient. So the discount rates that were used by the government, they used market interest rates, which I'll say something about in the next, 2.5%, 3%, and 5%. There are also a number of intergenerational rates, what are called intergenerational rates, some that have been cited here and there. So EPA, a technical support document, cited 0.5 to 3%. The Office of Management and Budget notes that the literature and economics literature 1 to 3%. We used 1 to 2% in our 2012 paper in the journal. The Stern UK review used 1.4%. And now you can see why the discount rate is so important. So if you have $100 of damages in 100 years, if you use a 5% discount rate, we count that as 76 cents. If you use a 3% discount rate, that's the central value of the government, $5.20. And if you use a 1%, that $100 will be counted as 37. Now, the problem with the market interest rates, as we see it and we argue, is that one of the justifications is completely not ethically supportable. And that is that we're impatient, but it's not our income that we're being impatient with. It's other people in the future, our children and our grandchildren. So it's one thing to say that, well, I'm going to incur some cost to myself in the future because I want more now. Within my own lifetime, that might be something you would consider as okay, that's my choice, but we're imposing this on future generations. So we are saying our consumption is more important than our children and our grandchildren simply because we are here first. The next problem with interest rates that you use in the market is that basically they're taking rates that reflect historical economic growth. We don't know what economic growth is going to look like under climate change. We do think that it may not be quite as rosy. There are definitely economic productivity impacts on our infrastructure. If we have continually fixing bridges and rail lines, et cetera, roads, that's going to hamper our productivity. If we have less water available, that's also going to be a problem, stable food supply. There's also worker productivity. So if there's more air pollution, people are sicker. They stay home more often. There's more asthma. There's more heart attacks. There's also people who work outside in the heat, so worker productivity effects there. And recent research is finding that these economic productivity effects are quite large and can be as important as the discount rate once you try to model them. We also don't take into account what's called a risk premium. So when you make an investment in the market, typically it involves some risk. You may not get your money back. It's not usually a good that you're getting risk reduction for unless it's insurance. So when we mitigate our carbon pollution, reduce our emissions, we're reducing our risk. So that this is not a typical kind of investment. We're actually reducing risk by doing mitigation. The different social cost of carbon values are on this slide. So the U.S. government ranges from $12 at a 5% discount rate per ton to $58, and this is in 2015, all in 2007 dollars. Our paper that was just published, we actually drew from the published values that we did in the 2012 paper, ranging from $62 up to $266 per ton. And now, the bottom line is, what does this mean for policy? So this chart is the government's, using the government's discount rate, central rate of 3% for emissions in 2018 and construction in 2018 of different generating sources. What you see at the height of each bar is a cents per kilowatt hour. This is once you internalize the social cost of carbon. We also have some other health pollution damages from sulfur dioxide. The three bars to the right, the brown and black colors, represent coal technologies. Try to be intuitive here. Yellow is the sun, solar. All the way to the left, sky, blue is the wind. Couldn't really have a good color for gas, though. That's what we have, pinkish hue. So wind is at 8 cents per kilowatt hour. 8.8 cents is the carbon capture with storage natural gas, and then the 7.8 is the natural gas, traditional. So what you see here is basically those three technologies, natural gas and wind, are desirable over the other alternatives. The black bar is your typical existing coal plant. So it's very cheap to run, but it has a lot of carbon emissions associated with it, and that cost, which is the combination why it's lower than the rightmost bar, that is a new coal plant. Costs more, just its basic cost to get up and going, as well as, but it's got less emissions. It's just not as cheap as the existing plant. The bar to the left of that, the 13.1 cents, is carbon capture and storage technology for burning coal. So that's your basic picture with a 3% discount rate. Just by way of comparison, the next slide is going to give you the 1.5% discount rate, which is roughly comparable to the Stern Review, which used 1.4%. So here you see is that every cleaner technology beats out the two right bars. Existing coal, typical petrochemical plant, 18.7 cents, that's black bar, and then a new coal plant is 20 cents. Following that, you have carbon capture and coal, then solar, the two natural gas technologies. In this case, the middle, the 9.2 cents is the natural gas with carbon capture. It's cheaper than natural gas because it has much less pollution. And then the hands-down winner here is wind. I want to say something just quickly going back to the slide. What's important about this that you should note is that that natural gas, the conventional 7.8% cents there for the conventional natural gas, does not include upstream pollution damages. So any kind of damages that occur to groundwater, air, et cetera, from fracking, transmitting pipeline spills, that sort of thing, is not included in that 7.8 cents. So arguably it's probably expensive, more expensive than wind. Wind is the winner here. Quick word on the government's update. So recently the U.S. government updated it. It used the same models it used in the literature in economics to estimate the social cost of carbon. Didn't make any changes in how it used those models. It just used the newer versions. But it's caused a very big stir up in the Hill and industry, submitting all kinds of Congress writing bills to stop the use of the SCC in regulatory impact analysis, to stop any regulation that's using it. Industry is making similar arguments. And it's not surprising because what you just saw from the slides is that it actually matters. It will affect the net benefits calculations of one technology versus another. Industry has drawn on an article by an economist named Pendyke. He was quite critical of the SCC, but his critique basically points to that the SCC is very underestimated, because his concern was that the damages just don't reflect catastrophic outcomes. And his argument was that the government's social cost of carbon could be a starting point for a tax. So his article was a big deal. It was used in a very distorted way by industry and other opponents. So with that, I will take your questions.
Okay. So the first question is, Pendyke notes the problem of how to deal with extreme events. How do you address this issue?
We don't. We just take the model that the government used and re-estimated it at different discount rates. So our estimates are conservative as well in that respect.
Okay. All right. The next question is, just to clarify, how many papers are there and from when?
Okay, September 2012. There was a publication in which I just described the basic models, the SCC introduced it, and then gave some applications in terms of how it would matter in setting standards. That gives you a lot of background on the discount rate, as well as some of the things that are in the models. The one that we're just talking about today, which those graphs are from, was another one, but it was just in September, so it's the second of two, and that looks at specifically a lot of these technologies that we looked at.
Okay, thank you. Next question, outside of the Environmental Protection Agency, which agencies are developing new models in this context?
I'm not aware. Actually, the EPA is not developing the model. The model is, I should say a little more about this. There was an interagency task force convened in 2009. What had been happening was all of the different agencies were using different values. There were disparate numbers in the literature. There's a lot of variance in these for different reasons. And one agency in particular, the Department of Transportation, the National Highway Transportation Safety Administration, did not use one at all. And it came before the Ninth Circuit Court, and the court said that NHTSA's reasoning was that there's no, there's too much variance. It's not a good number. And NHTSA, the court responded and said that's not a justification just because there's uncertainty in the value. We know it certainly is not zero, and they remanded it and made the agency use a number. And so what the administration did was convene 12 agencies and cabinet offices to come up with one number that would be used consistently across all the agencies. So EPA is using it, the Department of Transportation, Department of Energy, all of the different agencies. I feel like I'm missing one. I forgot one other part of the question I wanted to address. I don't think so, but it might come back to me. So go forth with the next question.
Okay. Next question. Can you explain the generation cost estimates again? I was not hold on. I was not aware that EIA incorporated a carbon price in its generation cost estimates.
Okay, great. No, it did not. What I did was, or what we did, myself and my co-authors, what EIA does is it has, it estimates a cost on a cents per kilowatt hour basis for energy, different technologies. You can take model plants or a typical plant and associate and look at how much emissions are coming out of it. So you could take the social cost of carbon, which is what I did, multiplied it by the tons of emissions, and simply divide it by the number of kilowatt hours that are produced. And then you can tack that on to the EIA's cost estimate.
Okay, great. Thank you. Next question. When you talk about catastrophic damage, do you mean things such as storm damage, which can be covered by insurance, or flood damage and have been estimated? These sort of things are the things that are usually quoted as causes of harm from climate change.
I wish the answer to your question was that those were the catastrophic damages, because Sandy certainly was catastrophic. Really, there's sort of distinction between really, really bad, like Sandy, and then complete catastrophe of the things, unknowns we don't know, or we reach some tipping point where we can't control anything, and something, you have negative feedback effects, like the examples I gave you, and we have the ice sheets, one or both of the ice sheets collapsing, each 20 feet of sea level rise. That's just a nonlinear catastrophe that would be unbearable. Things that there is unknowns. We know that that's a possibility, but those are really what we tend to think of as total catastrophes. It's possible that some of the temperature projections which have not been ruled out are literally uninhabitable. The human body cannot actually process the way it sweats, so it can't survive in some of these really extreme temperature potential outcomes. That's really what we're thinking about there. Okay,
great. Next question. Why are we using the U.S. discount rate as the climate change problem is global? The emissions in the United States will have some impact globally. Don't you think we should use a global discount rate to estimate the social cost of carbon?
That's a good clarifying question. So the discount rate is actually based on market interest rates and not that prevail everywhere. Well, we're looking at U.S. discount rates, but most discount rates, it's comparable. Other countries are using similar discount rates. That said, actually, the UK and France are using lower discount rates. They're using discount rates that are more in line with the intergenerational discount rates than we are. I think there's a strong case to be made for not using the high discount rates that we're using, as you can probably conclude from my presentation and the whole thrust behind the research. That's a separate issue from what's also important, which is what damages are we looking at? Are we looking at damages just to the U.S.? Are we looking at global damages? One thing that was a correct decision by the administration and by other countries like France and UK is to use what's called a global SCC, which looks at all the damages from our emissions, not just in the U.S., but also across the world. We do not equity weight those, so a dollar's worth of damage in Africa is treated the same as a dollar's worth of damage in the U.S. There's some controversies about this, but there's really, there's precedent, which is for using a global number, which is that the social cost of carbon as is global in damages. Carbon doesn't discriminate. It warms the whole atmosphere. So it's a unique pollutant that way. Similar to ozone-depleting chemicals. So the U.S. has been using international damages for ozone pollution since the beginning of doing those regulations. So that's a good choice that was made. Now, there's also spillover effects. There's no reason to think that the damages, what happens in Bangladesh doesn't come back to the U.S. It's an interconnected world. We trade with the rest of the world. If the trading system collapses, that's certainly a spillover effect to us. If we have massive migration from areas that are heavily impacted and we have international security issues and conflicts, that's definitely a problem for the U.S. So domestic doesn't really make sense in terms of trying to figure out what it means in terms of damages to us. So that's why we go with the global. But we also go with the global because it's a global problem, and we certainly wouldn't want other countries to only take into account their emissions, damages on them and not us. If they did that and if we did that, we're all worse off, and we're repeating the entire problem that climate change presents to begin with. We'd be repeating the same problem in our cost-benefit analysis and our mitigation strategies. Now, that's another way of, that's economists' way of saying of what's called the golden rule, which is do unto others as others would do unto you. But that's basically that argument. And then, really, if we have to take a leading position. If we don't use a global SEC, that's a terrible signal. It's likely to very much cause a problem for us in getting other countries to cooperate as well.
All right, great, thank you. Next question. If we were to incorporate catastrophic events in the SEC, would Lori suggest doing so on a purely expected value, that is, a risk-neutral basis, or would it make sense to use a risk premium?
Well, we should definitely be using a risk premium. This is many people view climate mitigation as a risk management strategy, which says, well, we have to pick a target. We want to minimize the potential temperature change to 2 degrees. This is what's been sort of considered a tipping point. And this is an insurance investment, really. So if you actually look at insurance markets, people will take losses. We give money to insurance companies every day, knowing that statistically we'll probably never, we're not likely to cash in on it. We actually lose money at the expected value. So this really actually suggests a negative discount rate. We're requiring a positive expected return on mitigation as if it's not a risk management proposition. In fact, I mean, the risk of, quote, not making a profit off of mitigation is when we know the cost of mitigation, and they've been estimated about 1% of global GDP, versus the risk of what if we're wrong and we don't do any mitigation. We should absolutely take the risk of mitigating, and besides which there's tremendous benefits from going to cleaner energy. We've got less dependence on fossil fuels, less fossil fuel pollution, less oil spills, not fighting wars for oil. There's just sort of an endless list of reasons why it would be good to have cleaner energy, quite apart from climate change. So it's the risk aversion thing is a critical argument, but you could also add many others.
Okay, great, thank you. Next question. Is there a plan to address non-carbon dioxide gases such as methane?
Yes, the President's climate plan does cover these other gases, and EPA will be looking at and has been looking at regulations, for example, for oil and gas extraction and other sources. So yes.
Okay, great. Next question. Life cycle analysis is critical to greenhouse gas accounting. There's a number of questions here, but let's see. I'll do them in order. What issues arise with application of the SCC value to LCA greenhouse gas emissions when you include direct and indirect greenhouse gas emissions, upstream and downstream sources?
We would love to be able to have that in the SCC. It's not in the SCC, which is why on that slide with the natural gas being 7.8 cents versus wind being 8 cents at the government's central discount rate, by far wind is probably a clear winner despite that 0.2 cents difference, which pretty much is insignificant. But if you were to add on these upstream and downstream costs, for sure, wind would probably be quite more attractive.
Mm-hmm. And the second question is, how can the SCC be used in the debate about U.S. exports of coal and LNG?
That's a great question. So advocates have been asking the State Department to, for the Keystone Pipeline actually, to count those damages, use the SCC to estimate what those costs are if we were to build the Keystone Pipeline. So it's a similar problem. The administration, State Department has thus far not agreed to do that, but we are advocating for it.
Okay. Let's see. I'm looking to see if there's any other questions. I guess I'd ask you a broad question, maybe expand a bit. There, obviously, your assumptions in terms of the optimal discount rate and that what the administration has used can make a substantial difference in terms of what would be deemed to be the optimal policy prescriptions going forward. How would you justify your discount rates, and why do you think the administration chose to use much more conservative ones?
Well, the reasons that we justify the reasons why the intergenerational discount rates, as I showed you, as they've been estimated in the literature, the reasons why they have been estimated and why they are much lower than market discount rates is because they take into account the fact that there's future generations. It's a very long-term time horizon. It's very high risk, the climate scenario. We're not talking about a standard market investment. Investing in mitigation has very, very long-term consequences. As you might have seen from that slide, a 5% discount rate for $100 worth of damages in 100 years gives you 76 cents. If you take that to its logical conclusion, it means damages in 100 years don't matter. So embedded also in market interest rates, as I said, are historical growth rates. So we do not. I think it's a bit of a stretch and a bit of a gamble and a bit wishful thinking or irresponsible thinking to assume that we're going to have these kinds of growth rates in the future under an increasingly disrupted climate. We could even have negative growth rates, right. And I think that's a real problem with market interest rates.
Right. But why do you think government consistently utilizes that paradigm? Is it simply a feint, or is there some philosophical rationale that is potentially compelling?
Well, there is a rationale. I don't find it compelling, but the rationale that the administration gave is that we can observe market interest rates, so they're more transparent, because it's something we can see. We can see what kind of returns people require based on what we see in markets. I don't think that's a very powerful argument, because these are, as I said, these are interest rates observed in a climate of not major disruptive climate change, number one. Number two, these interest rates include what we call the time preference. One of the reasons why you get interest on an asset when you lend money is because you prefer to consume it now. So part of what's in the discount rate is called a time preference. It's what you require to delay your consumption if you're going to lend your money to somebody. And that's not justifiable in my mind. These are different generations. You're asking them to forego their future consumption so that I can have more now. That's what a market discount rate is when you apply it over hundreds of years in climate change.
Great. Thank you, Lori. We have a couple of more questions. First of all, can you expand on how the social cost of carbon should be thought of in terms of thinking of a carbon tax for policy?
Sure. I think you can think of it as a minimum value because it's only for marginal changes. You can use it as a minimum starting point for a tax. What you really want to do is actually set a target, and what comes out of a target is either a permit price or an implicit tax. That may or may not equal what the SCC is, but what it is, actually, the permit price would be the marginal cost of reducing the last ton. That's not necessarily going to equal the marginal benefit of a ton that we're looking at with the social cost of carbon. What many economists argue for is a sort of a risk management strategy, which says pick a target, see what the marginal cost is associated with that, and set the tax at that. We're not setting a target. We're looking at a very small change in emissions when we're looking at the SCC, but it can serve as a starting point.
Okay, great. Thank you. Another question. Lori gave us several reasons why the current SCC is likely an underestimate of the true value. Are there any aspects of the current calculated SCC that could arguably be seen as overestimates of the true value?
Yeah, two arguments. One is that we may be able to adapt more. These models actually assume a fair amount of adaptation, so they literally just assume that some of the damages don't really happen because we do things to mitigate them. But you could argue that we are highly adaptive and we will create all kinds of new crops to deal with drought. We will build better systems of irrigation. We will come up with different technologies, much cheaper technologies. We'll figure out a way to capture emissions and take them out of the atmosphere, geoengineer them out. So technology may save the day. I think that's a big gamble. It'd be nice if it does. That'd be wonderful, but I don't think we should use it as an excuse to do nothing or do very little. So technology and adaptation are sort of the two main things that people might argue.
Okay, great. Thank you. Are there any other questions? I see nothing else in our chat forum at this point. Okay. All right, great. I think we will conclude at this point. I'd like to first thank Dr. Johnson again for her excellent presentation and responses to questions. And I'd also like to thank all of the participants who provided us with some excellent grist for discussion. And I would like to invite all of you in the future to participate in these ACE webinars, and also I'd like to encourage you to join the Association of Environmental Studies and Sciences, and also to take a look at the Journal of Environmental Studies and Sciences. For many of you in the work you do, I think it'd be an excellent source of research in this context, and I hope some of you will also consider contributing to the journal. And with that, I'll thank everyone again and conclude the webinar. Goodbye now.